Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about discrete probability distribution part 2 binomial distribution. And in this lesson, I'm going to first introduce the binomial random variables. Then I'm going to show you how to define the probability distribution, how to compute probability relating to binomial random variables. And the last thing of today is how to define the mean and the variance of a binomial random variable. So let's get started off with the binomial random variables. What are binomial random variables? Let's consider example 1. Your favorite fast food chain is giving away a coupon. With every purchase of a meal, you scratch the coupon to reveal your price. 20% of the coupons entitle you to a free hamburger, and the rest of them say, better luck next time. You go to this restaurant in a group of 10 people, and everyone orders lunch. What is the probability that 3 of you win a free hamburger? So there's some keywords here that you need to pay attention. 20% of the coupons entitle you to a free hamburger. That means for each of the 10 people, the chance of successes is 20%. That means 20% that one randomly chosen person among the 10 people wins a free hamburger. And there are 10 people entering the restaurant. So we can treat 10 people as 10 trials. And the 20% chance of winning a free hamburger for each of the 10 people is the probability of success. So here, if we say X is the number of people out of 10 who win a free hamburger, then this lesson, X is called a binomial random variable. So, definition. A random variable that represents the number of successes in a series of trials has a probability distribution called the binomial distribution. And we can do notation X follow binomial distribution with two parameters n and p. Here we will learn that n is the number of trials and p is the probability of successes. If you look at example 1, n in example 1 is 10 because we have 10 people, and p is 0.2 or 20% because 20% of the coupons entitle you to a free hamburger. So that means the probability of successes is 20%. So to recognize whether a random variable is a binomial random variables, we have certain conditions to be met. The first condition is a fixed number of trials are conducted. The second condition is there are two possible outcomes for each trial. One is labeled success and the other is labeled fail. The probability of success is the same for each trial. Number 4, the trials are independent. This means that the outcome of one trial does not affect the outcomes of the other trials. The last condition is the random variable X represents the number of successes that occur. So to verify whether a random variable follows binomial distribution, we basically verify these 5 conditions. And for convenience, we use n as a notation for the number of trials, and p is the probability of success. 1 minus p is the complement of the event is the probability of fail. So now let's do some practice. Example 2. Determine which of the following are binomial random variables. For those that are binomial, state the 2 possible outcomes and specify which is a success. Also state the values of n and p. Here you are given 4 situations. A fake coin is tossed 10 times. Let X be the number of times the coin lands heads. B, 5 basketball players is attempt a free throw. Let X be the number of free throws made. C, 10 cards are in a box. 5 red, 5 green. 3 of the cards are drawn at random without replacement. Let X be the number of red cards drawn. D, a simple random sample of 50 voters is drawn from the residents in a large city. Let X be the number who plan to vote for a proposition to increase spending on public schools. So let's consider one by one. Look at our situation A. A fake coin is tossed 10 times, so the number of trials is 10, which is a fixed number. There are 2 possible outcomes, either heads or tails, when you toss in a fake coin. And when you toss a fake coin 10 times, the outcome of the first toss does not affect the second toss. And also, the second toss doesn't affect any other tosses. Here, X is the number of times the coin lands heads. If we say heads is success and tail is fail, then X is basically the number of successes. Therefore, the 5 conditions of binomial random variables are met. So, X here is a binomial random variable. B, 5 basketball players is a term of free throw. So we have 5 trials. However, they are not independent because different people have different abilities in playing basketball. So the number of free throws the first players make is not the probability that the first players hit success is different from the second player and the others. So B is not a binomial random variables because the independence property is the independence condition is violated. So A is yes and B is no. Now we look at C. 10 cards are in a box. So we have 10 trials. 5 red and 5 green. 3 of the cards are drawn at random without replacement. So here, since we have 10 cards in a box and 3 of the cards are drawn at random without replacement, so once one card is withdrawn, there is only 9 cards left. So the probability of getting a specific card is different times after times. Therefore, one of the 5 conditions of binomial random variables in this situation is violated. Therefore, C is not an example of binomial random variables. Now look at D. A simple random sample of 50 voters is drawn from the residents in a large city. And let X be the number who plan to vote for a proposition to increase spending on public schools. So here 50 voters is the number of trials. And let's say voting for the proposition is success and not voting for that proposition is fail. So we have 50 trials and the probability of success is a fixed number as well, is a fixed value as well. And here X is the number of successes. So D here is an example of binomial random variables. We have 50 trials. 50 is a fixed number. 50 trials are independent. The probability of successes is the same among these 50 trials, and X be the number of successes. So this is yes, this is a binomial random variable. Next, how do we define binomial probability distribution. So for binomial distribution, remember for random variables, to define the probability distribution, we either make a table. Basically, we find the probability of getting any possible numbers. Here the same for binomial probability distribution. However, for binomial, we have a rule, we have a general formula to compute the probability distribution. So for a binomial random variable x that represents the number of successes in n trials, with success probability p and probability of obtaining x successes would be probability x equal to leader x is n choose x, p to the x 1 minus p to the n minus x. Here n choose x is n factorial over x factorial times n minus x factorial, and x takes n plus 1 possible outcomes, either 0, 1, 2, 3, or n. By the way, binomial random variables are discrete random variables. So we take whole number as the value. We don't have continuous value. So this is when the question asks you for the binomial probability distribution, you basically define n and p, because the binomial distribution is defined based on two parameters, and the number of trials, and p, the probability of successes. And p, the probability x equal to the leader x, is called the probability distribution. And also, if the question asks you to find the probability that x less than or equal to x, we basically sum up all the value of the probability at the point from 0 to x. So probability x less than or equal to leader x is summation I from 0 to leader x. Probability that x is equal to I, and this equal to summation I from 0 to leader x. N choose I, p to the I, 1 minus p to the n minus I. If a question asks you for probability that x is strictly less than x, here x is a whole number, so we basically just subtract 1 from x and change the inequality to the trig inequality to non-trig inequality. So probability that x less than leader x is equal to probability that x that x is less than or equal to x minus 1. It symbolizes the probability of getting less than 5 tickets is the probability of getting 4 tickets or less. So probability x less than leader x is equal to probability that x less than or equal to x minus 1. If the question asks for probability that x is greater than leader x, then we use complement rule. So probability that x is greater than leader x strictly is equal to 1 minus probability that x less than or equal to x. And we can apply the formulas, the sum formulas here, summation formulas here for probability that x less than or equal to leader x. If the question asks for probability that x is greater or equal to leader x, so first we use complement rule and then use one more step to change to probability x less than or equal to leader x. So that's how we compute probability relating to binomial random variables. Now let's do another practice. Example 3, the Pew Research Center reported in a recent year that approximately 30% of U.S. adults own a tablet computer such as an iPad, Samsung Galaxy Tab, or Kindle Fire. Suppose a similar random sample of 15 people is taken. Use the binomial probability distribution to find the following probabilities. A. Find the probability that exactly 4 of the sample people own a tablet computer. So here you see that there are 15 people sampled. That means we have 15 trials. The number of trials is 15, and that is a fixed number. 30% is the probability of successes. Here we assume that owning a tablet computer is success. So the probability of success is 30%. And for sure, these 15 people are independent. Whether this person owning a tablet computer does not affect whether any other people in the group owning a tablet computer. So if we say X is the number of people who is owning a tablet computer, then X followed by binomial distribution with two parameters, 15 and 0.3. 15 is the number of trials and 0.3 is the probability of successes. And the question asks for the probability that exactly 4 of the same people own a tablet computer. That means the probability that X equal to 4 exactly. So probability X equal to 4, we apply the formulas. That is 15 choose 4, 0.3 to the 4, 0.7 to the 11. And remember 15.4, 15 choose 4 is 15 factorials over 4 factorial times 11 factorial. We either can use calculator to find the combination 15 choose 4 using the formula, or we also can use the syntax on the calculator. On any calculator, we do have a syntax to calculate combination, and it should be like NCX on your calculator. So the answer for the first part is 0.2186. Part B, find the probability that fewer than 3 of the people own a tablet computer. Fewer than 3 successes. So what we can have either 0 success, 1 success, or 2 successes. So probability that X strictly less than 3 is probability of 0 plus probability of 1 plus probability of 2. This is 0.0047 plus 0.0305 plus 0.0916. Here for each of these terms, we apply the formulas of probability distribution. And the answer for part B is 0.1268. Part C, find the probability that more than one person owns a tablet computer. More than one, so X is strictly greater than 1. Here, if we use the methods that we use in Part B, it would create as a mess. Because if you start counting the number that greater than 1, we have either 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 15. And then we have to compute each of these probability and add them together. It's gonna waste a long time. So here's a hint to deal with this situation. Probability that X greater than 1, we can use complement rule. So is equal to 1 minus probability that X less than or equal to 1. And the probability that X less than or equal to 1 is basically just 0 and 1. So we got 1 subtract P of 0 subtract P of 1. So 1 minus 0.0047 minus 0.0305, and the answer is 0.9648. So that is part C. Complement rule is a powerful trick to deal with the problems relating to at least, more than, something like that. Part D, find the probability that the number of people who own a tablet computer is between 1 and 4 inclusive. So between 1 and 4, that means the number of people who own a tablet computer can be either 1, 2, 3, or 4. So we basically add in these 4 probabilities together. We got 0.0305, 0.0916, 0.1700, 0.2186, and we got 0.5107. Now, how do we, the lesson of today is how do we define the mean and the variance over random variable that follows binomial distribution. To compute the means, there is one single formula. We basically times n, the number of trials, with p, the probability of success. So that is expected value of x, or mu of x. This is the mean. And for the variance, we multiply n with p and times 1 minus p. So variance of x is sigma x squared, and this equals to np times 1 minus p. And the standard deviation is square root of the variance, which is square root of p times 1 minus p. Let's do one more practice. Example 4, the probability that a new car of a certain model will require repairs during a warranty period is 0.15. A particular dealership sells 25 such cars. Let x be the number that will require repairs during the warranty period. Find the mean and the standard deviation of x. So here we have 25 independent trials, and the probability of successes is the probability that a certain model will require repairs during warranty periods, which is 0.15. So the mean is just n times p. Apply the formula. So we got the mean as 25 times 0.15, which is 3.75. That means among these 25 cars, around 3.75, 3 to 4 cars will require repairs during the warranty period. And the variance, sigma x squared, is n times p times 1 minus p. So 25 times 0.15 times 0.85, the variance should be 3.1875, and the standard deviation should be the square root of the variance. So we got 1.79 for the standard deviation of x. So that's everything for today. Thank you so much for watching my video. I hope my video is useful for you to study statistics, and see you in the next video. Bye.